This is the materials that we are going to use for the first process, insulation. To ensure complete electrical insulation between aluminum and copper effectively prevents any short circuits, a plastic tube should first place over the upper section of the copper and aluminum. By using a heat gun, the plastic melts cover the part of the copper and aluminum that must be insulated. Another way for insulation is to have a divider between copper and aluminum inside the PCB tube. This will ensure that the two metals are separated from each other. Through using a plastic material cut into 4 pieces for each PCB tube, it will ensure us that there will be no short circuit and have a continuous electricity generation. The next process is assembling the copper and aluminum. In this second process, copper is specifically chosen for its exceptional electrical conductivity, making it ideal as the positive electrode anode. Its ability to efficiently transmit electrons ensures optimal performance of the system. Within each container or tube, thin strips of copper and aluminum are carefully arranged in an alternating sequence. This layered configuration is crucial for the intended electrochemical process. To maintain electrical insulation between the copper and aluminum components and prevent any intended short circuit, a non-conductive plastic divider is placed between each pair of alternating metal strips. Aluminum functions as the negative electrode or anode in this setup, while the copper functions as the positive electrode or anode. Its electrochemical properties in conjunction with copper facilitate the desired reaction within the system. Subsequently, a liquid sealant is meticulously applied to all openings and seams on the tubes. This setup vital to create completely impermeable barrier, effectively preventing any potential linkage of the sodium hypochlorite solution, ensuring safety and containment. After the sealant application, the entire assembly is then placed under direct sunlight for a minimum of 5 hours. This prolonged exposure to solar heat allows for true and complete drying and curing of the sealant, guaranteeing its long-term effectiveness. The third step is spraying with black paint around the tube, makes it in more good quality. This takes about 1 hour to completely dry the paint. The fourth process is to measure the sodium hypochlorite or Sandrox through using a syringe. We use 50 ml of Sandrox with a total of 200 ml. The process must be carefully conducted to prevent chemical spills around. The fifth and last process is the wiring connection where the output from the tube must be connected from the switch to the LED. The positive of the output from the sodium hypochlorite is connected to the pin 1 of the switch. The pin 2 of the switch is connected to the positive wire of the LED. The negative of LED is connected to the negative output of the sodium hypochlorite. This is the process of the wiring connection where, as we can see, the prototype is functional.